everyone, this is Math at School, and in this video, I'm gonna show you how I simplify this radical expression without using calculator. So, without further ado, let's go ahead and start solving this problem. Now, if you know the answer to this problem, go ahead and put your answer in the comment section below. Meanwhile, I am going to start solving this problem. Now, if you have a gigantic number underneath the radical sign, then you might get a little intimidated. But if you use my factorization tree method, then you don't have to get intimidated, trust me. Because you just start with whatever number you're given and come up with two numbers that when multiplied together gives you this number. It's not hard. Off the top of my head, since it's 60,000, it's equal to 60 times 1,000. So that's I'm gonna write. Now neither of these two numbers are prime numbers, so I'm not gonna circle, and I'm gonna keep breaking them down. 60 is equal to 6 times 10. 6 is equal to 2 times 3, and 2 and 3 are prime numbers, so I'm going to circle them. Meanwhile, 10 is equal to 2 and 5, 2 times 5 that is, and both 2 and 5 are prime numbers, so I'm going to circle them both as well. Now, this side of the tree is done because its extremities are all composed of prime numbers. So they cannot be further broken down. So I'm going to leave this side as they are right now and work on the right side of the tree. Now, 1,000 is equal to 10 times 100, obviously, and 10 is equal to 2 times 5. 2 and 5 are prime numbers, so again, I circle them. 100 is equal to 10 times 10. 10 is equal to 2 times 5 and 2 times 5. And all of those four numbers are prime numbers, so I circle all four numbers. Now here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that when multiplied together gives me 60,000. So I can rewrite square root of 60,000 as following. Square root of, how many 2's do I have? 1, 2, 3, 4, 5. So 2 to the power of 5. And how many 3's do I have? I have 1 and no more. So 3, and how many 5's do I have? 1, 2, 3, 4. 5 to the power of 4, or 5 times 5 times 5 times 5, or 5 multiplied 4 times. So those are everything. I have checked off all the prime numbers that make up 60,000. So I am going to put this factorization tree aside for your reference right here and keep on simplifying this. Now, only numbers or variables with with even numbered exponents get to escape the radical sign, and if your number has an odd numbered exponent, they have to stay underneath the radical sign. So what I'm going to do is I am going to rewrite all the numbers or all the variables with odd number exponent into two parts. So I'm going to rewrite 2 to the power of 5 into 2 to the power of 4 times 2, and write the rest as they are. Times 3 times 5 to the power of 4. And copy down the square root sign. And this way, I know that 2 to the power of 4 gets to escape the radical sign as 2 to the power of 2. Because when you're escaping the square root sign, the exponent gets half down, which means you have to have an exponent that's 1/2 of the original exponent. Okay, and another number, which is right here, gets to escape the square root sign as 5 to the power of 4 over 2, or 4 divided by 2, which is 2. Now, 2 to the power of 1 and 3 to the power of 1, unfortunately, those two numbers have to stay underneath the radical sign because they don't have its pair. Alright, so let's keep going. So these two numbers that escape, I'm going to write in front of the radical sign. 2 to the power of 2 times 5 to the power of 2. And then write the radical and write all the numbers that fail to escape the radical sign. 2 and 3. Okay, so what is that equal to? 2 to the power of 2 is equal to 4. 5 to the power of 2 is equal to 25. Square root of 2 times 3, 6. So that's equal to 100 times square root of 6, and that'll be our final answer. Well, so with my method, you will never have to be afraid of gigantic numbers underneath the square root sign, no matter how big of a number you have underneath the square root sign or radical expression. You will be able to conquer using the factorization tree and the escape rule that I just explained seconds ago. So this is it for you guys. If you want to practice more radical problems with me, I have posted my video lessons as well as worksheets and practice problems with video solutions to each on my website on www.mathit.school, and there you can practice many problems and check video solutions in subject areas like these. And you can access these by clicking the button that says Enroll Now. Thanks for watching, and I'll see you guys in another video. Please like my video, FYI, because it really helps me if you do. So like my video and don't forget to subscribe to my channel. Bye!